Hey guys, welcome back. These are some examples on calculating vertical forces. We'll start with example A. You have a mass of 80 kilograms. What is your weight? Remember that Newton's second law says that forces cause masses to accelerate in the direction of the net force. The net force here is going to be downward. Your weight is due to Earth's gravity pulling on your mass. So we'll just take mass times the acceleration of gravity, 9.8 meters per second squared, to get the force acting upon you. And again, that force is your weight. So 80 times approximately 10 gives me about 800 newtons, or 784 newtons. All right, now let's look at apparent weight. If your weight is 784 newtons and you're in a car or an elevator or on a roller coaster, the acceleration of the car, elevator, or roller coaster will change the total acceleration, which changes your weight. So what we're going to do for example B is say that you're in an elevator and it's accelerating upward. You're going to ask yourself if you feel heavier or lighter. If you are supposed to feel heavier in that scenario, you're going to add the 3 meters per second squared acceleration to the acceleration of gravity, because that's going to increase this factor, which will increase the weight. But if in the scenario you are supposed to feel lighter, then you're going to subtract that 3 from 9.8. So let's picture this. If you're in an elevator that's accelerating upward, then due to inertia, your body wants to stay put, and that floor of the elevator is going to push up on you more, so that's going to increase your weight. You're going to temporarily feel heavier. That means your apparent weight will be greater than your original weight. So we're going to take force equals your mass, 80 kilograms, times a new acceleration, which is 9.8, plus the 3.0 acceleration of the elevator. We get 1024. So when the elevator accelerated upward, we went from 784 newtons to 1024 newtons. Okay, now the elevator slows down at the same acceleration before letting you off on the 3rd floor. So is your apparent weight going to be greater than or less than your original weight? If it's slowing down and you're heading upwards and it's slowing down due to inertia, your body still wants to go upwards. So you're coming up off the floor of the elevator. If you were standing on a scale in the elevator, your apparent weight would be less than your original weight. So what we're going to do is take that 3.0 and subtract it from 9.8. $544. So our weight went from 784 newtons standing still to 544 newtons as the elevator, as we came up off the floor of the elevator, as it was going upward and it was slowing down. All right, example D. For this, we're going to have to apply some kinematics equations. In example D, we're lifting a bucket. The bucket has a mass of 50 kilograms, and the rope will not break if the tension is 525 newtons or less. Now this is very important that we do not plug in 525 newtons into the equation. This is a comparison problem where we need to calculate the force of tension in the rope and then compare it to this. If it's less than 525, the rope will not break. But if the tension is greater than 525, the rope will break. And that's the thing about ropes, strings, springs, chains. When you purchase these, they each have ratings based on how much weight they can pull. So the bucket starts at rest, and after being lifted at 3 meters, it's moving 3 meters per second. So starting at 0 and reaching 3 meters per second. If the acceleration is constant, is the rope in the danger of breaking? We want to find the acceleration, and when we get the acceleration, then we can multiply that by the mass to get the force of tension. So we're going to apply our kinematics equations where we don't have time here, so we're going to use that formula that's derived without time. The final velocity in the y direction squared equals the initial velocity in the y direction squared plus 2 times the acceleration in the y direction times delta d in the y direction. So the final velocity is 3. The initial velocity is 0 plus 2 times the acceleration, which we need to find, acceleration in the y direction, times delta d. We go from a final position of 3 meters minus an initial position of 0. Okay, so we have 3 squared, which gives us 9. And then 2 times 3 gives us 6. And 9/6 is our answer. .5 meters per second squared. Now we can find the force of tension when it accelerates at 1.5 meters per second squared. The force equals mass times acceleration. The force is going to equal the bucket's mass, which is 50 kilograms, times the acceleration, not just this acceleration, but we have the initial weight of the bucket, so we need to do the 9.8. Okay, 9.8 times 50 would give us the initial weight, but remember it's accelerating upward, so we're going to add 1.5. We're adding it because if we pull and accelerate upwards, we're going to make the apparent weight greater, so we're adding the 1.5 acceleration. And we get 565 newtons. That is greater than 525, so yes, the rope will break. Okay, example E. We have a 0.11 kilogram apple hanging from a rope. What is the force of tension in the rope? And then we're going to hang a 0.09 kilogram orange from the apple and find the new tension in that rope. And then we're going to find the tension in the rope between the apple and the orange. So here's the apple. It is 0.11 kilograms. Here's the orange. It's 0.09 kilograms. And for the first question, we want to find the tension in the rope of just the apple. So we're just going to take that 0.11 kilograms of mass, multiply it by, you guessed it, 9.8 to get the weight. And that gives us about 1.1, because times 10, we're just going to move the decimal over, newtons. All right, for the second scenario, we want to know what the tension in the rope is after we add an orange to the system. So now we have 0.11 kilograms hanging from that rope plus 0.09 kilograms of mass hanging from that rope. And we're assuming this rope is massless. Times acceleration gives us 1.96, or approximately 2. Lastly, we want to know what the tension in the rope is between the apple and the orange. So now the only mass hanging from that rope is the orange's mass. So 10 times that gives us about 0.9. That's it. All right, have a great day. Thanks for learning.